The velocity function for a particle moving along a line is given by 2t minus 6. Oh, this is a linear, first degree polynomial, so linear meters per second. That's the velocity function. On the time interval 1 through 4, find the displacement and the distance traveled by the particle during the given time interval. So 1 through 4, displacement and distance. Okay, they are almost the same concept but not exact. Okay, if something is going on a straight line in one direction, then displacement and distance are same. But let's think about elevator. Okay, suppose you started on the second floor and it went all the way to 5th floor and came back to 3rd floor. Let's say, okay, started at 2nd floor, went to 5th floor, came back to 3rd floor. So the displacement is just 1. Okay, 1 up plus 1. But the distance traveled is what? 2 to 5, 3 up and 2 down. So the distance traveled is 5 floors. 3 up, 2 down, so 5. But the displacement is just 1. So you can think in this way. But if you are going in the same line forever, straight line, then the displacement or the distance traveled, they are same thing. So here 2t minus 6, this velocity, this may be 0 at some point in between 1 and 4. So 2t minus 6, 2t minus 6 is 0 where? At 3. Or you can solve add 6 both sides, divide by 2, so 3. So 3 is in between 1 and 4. So velocity negative and positive means going right side and coming to the left. So like the elevator going up and down. So now let me do in 2 different ways. So this is linear, so we don't have to use calculus in fact, but let's use calculus. First, so the displacement is pretty much the definite integral 1 through 4, okay, of this function velocity. 1 through 4 definite integral velocity is 2t minus 6. Now let's integrate 2t, that's t squared. 2 times t squared over 2, 2 cancel, just t squared. Or you can think of derivative of t squared is 2t. Okay, minus antiderivative of 6 is 6t. Now 1 through 4. Plug in upper limit, 4 squared, 16 minus 6 times 4, 24. That's the upper limit, minus lower limit 1 squared, 1 minus 6. That is negative 8 minus, that's negative 5. Negative 8 plus 5, so negative 3. Okay, so that's the displacement. Now the distance traveled is 1 through 4, but we need to take absolute value because distance left or right, still we want the distance to be positive. So absolute value of dt dt. And to get rid of this absolute value, otherwise we cannot work, we need to take outside, and then we need to take this into account because this function, velocity function, is 0 at 3. So we can divide into 2 parts, 1 through 3 and 3 through 4. So I divided 1 through 4 into 2 parts, 1 through 3 plus 3 through 4. Pt dt. Now we can put this absolute value outside. So pretty much this is 1 through 3. Now velocity function is 2t minus 6. Same thing here, okay, my bad, just the absolute value outside. 3 through 4, 2t minus 6 dt. Okay, that is, let's integrate, and we're going to take, at the end of the day, absolute value. So 2t minus 6 is same thing like last time, t squared minus 6t, and we're going to do from 1 through 3 and take absolute value. Here again, t squared minus 6t, we go from 3 through 4 and absolute value. Plug in upper limit minus lower limit. So 3 squared 9 minus 6 times 3, 18. 9 minus 18, negative 9 minus, plug in 1, 1 minus 6, negative 5. And to take absolute value. Plus here, 4 squared, 16 minus 24, it's negative 8. Okay, we have absolute value. Minus lower limit, 3 squared 9 minus 18, negative 9. Okay, negative 9 plus 5, that's the negative 4. Absolute value of negative 4 is simply 4. Okay, plus negative 8 plus 9. Okay, this is negative minus 9 means plus 9. Negative 8 plus 9 is just 1, and the absolute value of 1 is 1. 4 plus 1 is 5. So the displacement, the displacement was negative 3 units, while the distance is 5 units. Okay, but this is a linear, 2t minus 6 is simply a linear, it's a line, so we don't need calculus to solve. So alternatively, let me do over here, alternatively, we can simply graph that 2t minus 6 because it's so simple. Let me graph, or you can use your calculator. The function is 2t minus 6, right? Okay, we are doing alternative way without calculus, by the way. Let's to graph simply 2x minus 6 in your calculator, or just use this table. At 0, that's negative 6. At 1, negative 4. At 3, need a couple of points. Okay, only 2 points would be fine, but I'm finding more. 2 times 3, 6, 0, and maybe 4 is 2. And now let's graph this. Okay, let me try to draw a better line here. Okay, and our goal is to go from where? 1 through 4. Okay, so, but the graph is okay, 0, negative 6, 1, 2, 3, 4, 5, let's say 6 here, 0, negative 6, 1, 4, 1, negative 4, 1, 2, 3, 4, maybe here, 3, 0, and 4, 2. Okay, 3, 0, so this is the line. Doesn't have to be exact. Okay, this is in fact the function 2t minus 6. Okay, here 3 at 0, at 4 this is 2, and at 1 that's negative 4. See, this is negative 4, negative 6. Okay, and we are asked to find the displacement and distance traveled during 1 through 4. So let's look at this graph. So 1 is here, 4 is here. So the definite integral is pretty much area under the curve. So from here the curve is below. So we need to deal with this triangle, because at 1 the graph is below the x-axis. So this triangle, and another triangle is 1 through 4, right? Is 4 is here, and this is the triangle. Okay, so we got two triangles, and the net area will be the displacement. I mean, this one is considered negative on the bottom, and if we take the area, in fact area is always positive, that's the distance traveled. So in part A now we can answer displacement is net area. So what is the area of this triangle? That's the half times base 1 through 3, that's 2 units, and 1 through, this is 0 level through -4, that's -4. Okay, 2 to cancel, -4. So area of triangle is 4, but it's below x-axis, so we are talking about negative. And how about this one? Half times base 3 to 4 is 1 unit, and this height is 2. 2 to cancel, just 1. So displacement means the 1 plus -4, or 1 minus 4, which is -3. Okay, that's what we had earlier, -3. Now the distance traveled means we need to take positive. Okay, distance traveled is, we need to consider positive, okay, because the area, not the net area, it's area of this triangle, which is always +4, and this is 1. Okay, and that's what we had earlier. But if this function is not linear, 2t minus 6, then we cannot use this alternative way because we don't have triangles, and then we cannot find the area. So the first one always works for any function.